All right, next on the list is design sub-agent output schemas that render structured data, prose summaries, and citation metadata in a format best suited to downstream synthesis and reporting. Once again, it sounds extremely complicated and is actually quite simple. And I'm pretty sure for the test, I overthought this one quite a bit. So what we're talking about is the fact that when you have multiple subagents, those subagents try to return data to you using human readable form. So in other words, if you're talking to Claude, Claude responds back in a chat type of session. The subagents do exactly the same thing. They're all different instances of Claude code after all. However, what's reading the information that the subagents return is not an actual person, but instead either the parent agent, the orchestrator, synthesis agent, or maybe even a script. So this synthesis agent needs to be able to grab all of this data that these subagents returned, make sense of it, and potentially report on it. And this causes problems because open-ended text historically doesn't work well for these types of issues. You lose some certainty there. For example, two subagents may review the same file and arrive at a slightly different conclusion. So which one do you go with? And there are basically lots of problems that we can look at from this example. So the first one is this unmergeable data. And this is exactly like I said. Data could be conflicting, duplicated, or we may be double counting something because multiple agents looked at the same thing. And at that summary, at that higher level, we're just going to count all of those instances, even though it's really the same file. So we can't necessarily just rely on prose output from the subagents. We need to give them some sort of structure. And so essentially and I'll show you the schema shortly, create a JSON output that ensures that each agent responds within that structure. And this is enough for us to deal with most of these unmergeable data conflicts. But of course, this brings up a second problem. And that second problem is that when you lose that open-ended text, you may also lose the why it matters. And this is something that is important because you may know that an agent came up with this particular summary and, is basically telling you like, well, this is a high priority thing that you have to deal with. But how did it arrive at that? Like, why? And so we need something there that contains that context. Like, how did you get there? And so we can allow that JSON to include some of that open-ended text that we can then rely on to determine whether or not this is really a thing that we want to look at. So the next option or the next problem is that the uncertainty from subagents could be lost or altered. So we need an explicit confidence level on each claim. So this again goes back mostly when you're reviewing documents or code and it says, oh, I found a vulnerability and it's a high one. So how did you get to that? What is your confidence level around the fact that this is a high vulnerability that you found in our code? So because these agents do some reasoning, we can set an explicit confidence level, which is a specific number like 1 through 5. And the agent has to pick that as part of its output. This will reduce its ability to send us off on a wild goose chase when the confidence level on something is relatively low. The next item is that we need to be able to trace the subagent's claim to actual data. So we must include citations in the metadata. And so this boils down to if I reviewed 10 files, somewhere in there, I need a citation as part of my output that's in JSON that tells me that here's where I found these particular things that we need to address. And last but not least, subagents may not find anything in particular. They may return nothing at all. And so if that happens, is that really that we didn't find anything, or was there an error, or did something else occur? So subagents should show the coverage of what they found and report what they did or did not do. So this is important because it forces them, even if you get no specific answer back from that subagent, to explain what it is that it did to get to that no answer scenario. And speaking of scenarios, let's take a look at how this plays out. So the first one, again, we said unmergeable data. And we said to fix this, we need structured fields. We're basically going to create a schema, which looks exactly like this, that forces the subagent to return the data that it finds inside of this JSON output. And you can see in here we have several claims. We have a confidence level. We have a summary, which is that context, like how did you figure this out? We have coverage, which shows which files were examined. And we have even open questions. So throughout the rest of the scenarios here, I'm really just going to refer to one or more lines within this particular schema, because this sort of covers everything. But this creates the thing we need in order to make sure we get consistent output from the subagents, that we can parse it, read it, summarize it, and deal with it in a high degree of confidence. All right, so number 2, we said that, we lose context because now that we switch to returning everything as structured data, that paragraph of text of Claude explaining how it got to this information is lost. And so by including a summary, which is just Claude's content that it wants to share with us, we can get back to that particular information. So we can look at that and we can say, oh, okay, so this is why Claude thinks this is a problem. Next one is wrong certainty. So subagents may return something as possibly or unclear if in production, but the synthesized report states these things as facts. So in other words, subagent looked at something and said, well, I'm not sure that this is really in production, but here's what I found in dev. Now, the parent agent, the one that summarizes and creates the report, basically says, oh, okay, so we have this issue with auth, and just kind of ignores the fact that the subagent said, well, I don't know that this is in production. This may not be an issue at all. And so what we do is we set up a explicit set of confidence levels. These could be low, medium, or high, and they should be enums. So essentially, we're always going to use those values and then possibly trigger some sort of a filter or something on these particular values to make sure that we cover off on anything with a high level of confidence that we definitely want to look at and fix. All right, then the next one is untraceable. So this is where subagents report something, but we don't know where it found the information that it did. So this could be a hallucination, or it could be that it's buried somewhere in the code and we just don't know where it is. So by including sources, we now know which specific lines and files are the ones that the agent looked at to arrive at its confidence level and its claim. Next, we have the no response from subagent. So this is where it's possible that nothing could be found, or we never looked, or maybe the prompt wasn't strong enough for us to figure out what to look at. So the answer here is to include something called coverage and open questions on JSON. This lets us see whether something was actually done. So essentially what this will do is force the agent to write something here that says, okay, I went and I looked at these files and, I did all of this stuff. And even though I looked at all of this stuff, I didn't find anything worthwhile. So we can then decide whether or not this is something, or if we had, bad prompt, or there's some other issue causing a problem. And so to wrap this one up, the last piece of this is that the exam may attempt to trick us into believing that the output should be for human consumption. And we always have to keep in mind that, if you're talking about an orchestrator and subagents, it's the orchestrator or the synthesis agent that's going to be reading this information. And so therefore, we need to be able to output it in something like JSON that this orchestrator or synthesis agent can read and work with. Okay, well, thank you for joining me today. I hope you've enjoyed this video. Like and subscribe, and I'll see you in the next one.